Hello and welcome back to another video. I'm going to look at the C64 Saver 2.5, which is the SMD version. The reason why I wanted SMD was because then I have space for LEDs. So anyway, this video has been sponsored by PCBWay. They are now 6 years. Really happy to get boards from them. So I'm just going to start this video by showing you what I've done, and I will just tear them apart. I made these two into Hammond boxes. I managed to cram in a DIN connector there, and this video will basically be a soldering video, long soldering video. So first I will just show you this box, because it was really hard to make this box, and showing you how to solder DIN connectors is really boring. So okay. So we'll start with tearing this one down, and then this one. Alright, so let's see what's in here. Yeah, DIN connector. Haven't got the screws for it yet, that's okay. So it was really hard to get those two holes right, but because as you can see, the LEDs they have to be the correct height. There you can see the panel mount. So this one goes to there, and this one goes to over here. So basically, if I want it out, it's not really possible anymore because of this connector in the other end. But I can service it like this. So this one is just bent over these two, and I have an insulation tape because they are a bit close. So that's basically it here. So you will see the soldering and everything. Yeah, so you can use a cable relief also. I also had to cut away those mounts there. You can see one over there. Yeah, just to get the board to sit at the bottom, such that this one didn't get too high. And then I used a diamond file to file down this side. So you have to watch the video to see how it works. I test it later in the video though. So this is the other one. This is the one with the add-on board. It has a little button here and a 128 by 32 pixel OLED display. So yeah, and I cut this hole myself. Probably you can see it because they are so close up, but I used the diamond file here too to get it right. So yeah, let's see what's in here. Alright, there you can see the board. It's the insulation tape. It's been glued. I actually had to remove the glue that was between the OLED and the OLED PCB because it had too much height. Also, one of the problems is that this add-on board is actually a bit too high. So, but this is cool. I got everything to fit with a scream. And here you can see the programming connector. So the firmware isn't complete. There, for example, the 9-volt current is not showing, it just shows the ADC value. So let's see how I did this. Here you can see the bottom board is the Saver board, and I don't have a connector there. I just have pins going through and through. So it was hard to get that right too. So, and there you can see the button. It's not soldered yet actually, so therefore it's a bit flimsy for now. I just needed to find the correct button. This add-on board is a prototype, and that's why you have these changes that I made late. So the way this works is it has, I've talked about this before, but it has opto-isolators, and I made the decision that the add-on board is powered by 9 volt AC, therefore we have some rectification going on here. And on the 9 volt side we can measure 9 volts, so I have the controller on 9 volt actually, with a 5 volt regulator though, but it's on isolated on the 9 volt side. And then on the 5 volt side it has a INA from Texas Instruments. It measures 5 volt and current. And there's a opto-isolated I2C bus that it's one of these two chips which sends the data back to the microcontroller in an isolated fashion. Now, why do I need this large, big ass? Why do I need these large opto-isolators here? Well, if you look here, this goes down into this connector here, and the signal goes further into the saver. So the saver works as normal, and but the P gate of the PMOS, or the switching transistor, which you can see there, right there, it can be switched off by software. So, but since we are running on 9 volt AC and we want to keep the isolation, I have isolated that also. So I spent some time to find these actually, because these are I think they're called open collector opto-isolators. And what that means is that you put a current on the input, which goes through an LED actually. And then on the other side, it doesn't matter what the voltage is on both pins, because that's important. Because we just want to clamp two points together. We don't want to have one on certain voltage and such. So that looks cool. So they're pretty normal. It's not difficult to find actually. You may also notice that something is missing here. The screen I bought in 2005, which I've been using for like almost 14 years or something. Something was wrong with the power supply, and it was kind of my fault, and I was going to fix it, but there was so many parts to fix, I didn't bother. So I was thinking maybe having a sticker here. Okay, I'm switching to my phone now because we need some charge going. I bought parts for it, lots of parts. No, I don't get that customs. Now that is solved, because I got a really high fee. But then you have to see the KU motherboard video. Anyway, PCBWay, they have sponsored me for the C64 Saver 2.4. Here you can see it, and it's an SMD version. Why did I go all the way to the SMD? It's because I needed to have fitted two more components here, the LEDs. So this is the old design. You can see it's all through parts except for the MOSFET here. And this is the 2.4 board from 2018. Anyway, we got a stencil. So I've been using it for the first prototype I made. And so I just made a provisorisk or a makeshift PCB holder, so I can just drop this board in there, and then I can like go over like this and align, smear, and there you go. They also sent me this ruler from PCBWay, really nice. I think I showed you this in the previous video, but this is the sponsored video anyway. So, and also this badge thing. So I think I will be making 1, 2, 3, 4, 5, and I'm gonna take this also and make boards out of these. And then okay, that's the 6th one. 4, 6, and then there's 4 here, so that will be 10. Yeah, maybe I should just make 7 now, because this rig is working so nice anyway. Now I have some more space in here. So yeah, gonna have some solder, gonna have some quick fix, I'm gonna get all the things I need up on here. All the stuff I got. Look, this is a box I have up on the shelf. Epoxy, some fake Amtech flux, sockets, large diodes from another project. I have much. These are really handy. Look at this. This is also useful for the building of the saver, so we'll take out. I need this one. This is, I don't know what the thickness is. And the next thing we need is, of course, some ChipQuik solder paste. It comes with a syringe and for one syringe. So if you buy the fake one, or not fake, but the one on Banggood, for example, you then get the syringe, which is kind of weird. But that was very useful to have, and you have a. You can apply with these syringes, but I'm not going to use the syringes. I'm just gonna paste something out on the board and use a credit card thingy. So I have crocodile clamps. I have, these are really, yeah, I need these. These are diamond files. I have shown that before, I think. This is something Ingrid bought for me. It's ammonium chloride stone. Not sure what it's called really, but it came with some flux and these stones. You can actually clean your tip with it. Look, there's a guy. He has cancer now, by the way. Oh, I hate when that happens. He stopped doing his hobby and he sent me this really nice keypad thing. Look at this. I don't know if you can buy it anywhere. I'm not sure. It says radar, I think. Here's radar. Vue Coutier Boutons. I'm not sure what it means. Made in France. So if you know something about this brand, Sadar or whatever it is, let me know. Not sure what I'm going to use it for, but these are really nice. It has this rubbery thing around it. There was a guy I met on Facebook regarding Thunberg radios. These are the boxes. It comes with 2 screws and everything. So yeah, nice to have boxes. And I have written on all the packets. Like Q1 is for Q1, so you can see on the board here. There you go, Q1, R0, D1 and so on, or R8. So, and here is my travel card, and we used it for paste. So I just put it in here so it won't mess up everything. Okay, here we go. So the first thing I will do is to clean up the mess from last time. So I think I will clean all the boards first, like here, so the solder will have no problem sticking. Don't know if I actually have to do that, but let's do it anyway. Let's clean with a clean side them. Anyway, if there's solder residue, it will just melt anyway, so it's probably not that bad anyway, but I think if there's grease on there, maybe it's not going to stick so well. Huh, there we go. Yeah, found it here. And yeah, anyway, I'm going to squirt out some of this stuff. ChipQuik TS391 AX. Alright, so let's just take off the safety cap here. The cap anyway, it's not safety cap. So I'm gonna squeeze out a fair amount because I'm going to apply for several boards. Alright, so oh, I have these also. I forgot to show you. I'm going to have a rant about this. Just wait and see. Yeah, and it's not what you think. It's actually against the common opinion about those, because people are constantly saying that they are bad, And what they are saying is actually, or what I'm talking about, are the eBay ones. These are not from eBay, they are from Mouser. So they are called, yeah, you can see the part number and everything. They are a bit more expensive than on the eBay, but they are made by CUI. You can see they are very similar to the ones, but they have all metal pins, and I can tell you, the one on eBay, they are filled with some kind of stone or something, I don't know. So they break really easily, and also you can hold your solder iron for 20 seconds without melting the plastic. So people are talking about putting these into potatoes. Well, you don't have to with these guys. So just buy the real thing, god damn it. That was the rant. So I did warn you. So oh yeah, now I found what I was looking for, and now I threw it away. So because I got so ranty. Oh, there it is. It's right in front of me. Yeah, this has been in a bag, so we'll just reuse it. Okay, just check that the alignment is okay. You can see if I do this, it's out of align. Yeah, there we go. So just apply firm pressure. There you go. There was one, I didn't get any, so I might have ruined it now, but just gonna scrape away here. So let's see how that turned out. What do you think? No smearing and nothing problem. So that's good. So I can pick up stuff. So I'm just gonna put this to the side, and as you can see, with the side light, you can see all the shadow from the solder paints there. So that's great. So let's put that on the side. Put it away so you don't accidentally smear it out on something. So it's also important to have all this around here, because or else the sheet will flex a bit, and then you won't get vacuum, or you won't sit flat anyway. Vacuum. Who's talking about vacuum anyway? Vacuum. So let's bring out all the components, and then I will continue from there. Oh, it's nice to make a video again. By the way, I'm using again the microphone, and this is me, as you can see. And I don't know if I have autofocus or whatever. Yeah, so as you can see, I am wearing the microphone here, so a good audio, bro. Yeah, so let's just bring out the boards, and I'll put it in a way that it's easy to apply components. So when you look at it like this, you can see that it's not the best way for holding your hand. So when you solder, or you use in general, you use your tweezers, you want your hands to be flat like this. And because if you stand like this, look how much it shakes like this. It's hard to keep it still, but if you rest, like you just put your hand like this, look how smooth it is. It's not moving at all. Now if you just move a series of fingers like this, you have a lot more control. I can pick up this little thing here. Anyway, so what I'm saying is that if I put it on the side like this, it will be easier to put down the component and without touching anything else. So. And also I will set up the camera so I can watch at the same time as I do this, because I really need to get my head in there. So the reason why I do this is because then I can say, okay, I need a component. I have R1 and R6. Okay, then I will put R1 and R6 on everyone. So let's start with these two. Let's put it off. I'm holding it so it doesn't fly everywhere. And then I'm gonna just dump it on the table. So now most of them are the wrong way, so we have to deal with that. And let's start R1 and R6. So just gonna put them up here so I don't smear them. Let's see, R1 and R6. Let's see, where is R6? It's there. So that looks good. R1 and R6. Then the next one. R1. R6. Oh, that's good. This time I'm going to zoom you in. There you got R1. R6. So we're gonna do the hot air thing later. I'm talking and I'm not concentrating. R1. It's also good to take some breaks so you can check your work. Not everything afterwards. But checking it afterwards is also very important.
Hammering it makes it harder. The more it is hammered, the harder it becomes.
I have my little copper board here, and then the desoldering station, which you've probably seen before. So I'm gonna start off at 300, and this time I think I will try and find the smaller tip for this, because when I did this the last time, I actually let's get the boards out anyway. I will bring you closer up soon, and I will save one board such that I can show you under the microscope what it looks like, but that I have to set up, so I will wait with that one. So it will be only these 6 first. So yeah, so first let's find the tip for this. Just take it off. Here, I think I have something up in here. A little this and that thing of a bob thingy. These are add-on boards for Saver, by the way. Let's see. Yeah, I've turned off power, by the way. So let's turn it on again. There. 350. It's a bit much. So 300. There you go. So pick it up. You can see it rises to about 300 there, really fast. There's an undershoot there. Yeah, so you can also see the PWM there flashing. So I'll just start and hover. Let's try the big one. The board underneath is heating it up, or pulling heat away from the board. So just give it some insulation. I'm about 2 centimeters from it. Something should happen very soon. There you go. So it's starting to melt. So I'm going to getting a bit closer now to get the heat going. There you go, it popped into place. Okay guys, I have this one up here, the Atan, and then the microscopes. Gonna show you some footage, and then I have this small SD card. Just put it in here. Oops, the correct way anyway. Hope I haven't broken anything. Just a quick video. I bought myself an Andon Star microscope, and it has a screen which is quite nice to use, and then you just need to power it up basically. So there it came with a HDMI, but if I use the HDMI then this display doesn't work. So I really like using this display. I know people like to use the HDMI. So it's just a small round barrel jack in the back, and then there's one up here for, so that's just for lighting, and this is for USB. So this is for powering the unit, and then let's see what happens. There you go. We have the remote control, which I've taped here. So I'm also going to use, let's start recording by the way. No. There, it's recording. Right. So now I'm going to get this board. I'm going to put the piece of cardboard here. So we don't get, because this frame is aluminium, so we'll just suck out all the heat. I don't remember, I don't know if you remember that I soldered 144 pins the wrong way. And then I tried to desolder it while it was on here and it didn't work. So yeah, it was this bed here. So the problem now, it's just too close. So okay, there's a break on the back here, I think. Let's see. Yeah, so this is what we're going to work with there. So if we want to see something, we will have to move it around. It's just too darn close. So let's try something like this. And here we go. I'm going to try the same temperatures. So there. I don't have too much room to work with here, so there's better lighting too. So that's nice. Oh, you can see it's soaking. The flux is melting. So soon I will just move closer in. Just going to see this. Actually, under this microscope. Hold on, I'm not supposed to stop like this, but just for the record, we're gonna move in and we're gonna see the solder balls. So let's see. There, can you see it? The solder paste is actually solder balls. You see that? Yeah, so while we do this, I'm going to zoom in just for fun, see how they melt together into one solid piece. And for now we're going to have the outer view like this. Let's get it back there. Okay. Focus. Like this. It's funny to see how the display, how everything is wobbling. Oh, there's something's going wrong. This is going to tombstone for sure. Hold on. Yeah. There you go. Let's see. Now it's moving away again. There you go. Yeah, it's like Terminator. Alright. Let's see if we get some from the backside here. It's so awesome. Look. And there that goes. As I said, it was the wrong component and everything. Those diodes are actually, or diodes, they are actually not the correct size for the pad. So we're just going to take some of these and then I'm going to zoom all the way in here. See how they reflow like that. Let's see if there's someone I haven't soldered yet. Like there. It's like cameras from the 1970s. You have to focus yourself. So here. Oh, it's too close. There you go. Let's try this one. Let's see. I'm keeping it at a distance now because I want to see it happen slowly. So it's so fun. Look at all those little marbles around there. Am I looking at the correct part anyway? R8. Yeah. Oh, there it goes. I almost missed it. Oh, that's beautiful. That is so beautiful. But why isn't it licking up on the sides? Oh, there it goes. There it goes. There it goes. So. Yup. I think that's solid. There you see it. There. That's solid. Then the neighbor. Oh no, that's not good. That's not good. It's hard to work when it's so close, by the way. Oh shit. Maybe it's already hot or just... Yeah, I was fooled. Look, it's actually hot. Yeah, that's good. There you go. Okay, so now this guy, I think that one is almost done now. Alright, so the microscope has stopped recording. Now it's recording. I don't know if it's just full or something, but sorry for that. I did, so I probably lost some footage, but let's see what I did. I don't know where it stopped, so I'm holding it on the side. You can see the tin is licking up on the sides, and that's why I'm holding this on the side. So if you have a stereoscope, that's much better, but I don't have that, so I have to tilt and look. But there you can see D2 is disoriented, if you can say it like that. So when I see that, I just put it away, and I will plug in my pattern again, because we need to fix that. So let's see. Looks good. This one is a bit too much on the side, so if you look at it like this, you can see it's not This is the problem I have with these. They are the wrong size, so I think all looks good here. This one, yeah, could have been a bit wide. So this looks good, right? D2 there. Then all the other guys look fine. Then you have this Q2 thing. This time I'm actually sitting down, so I can't find my tweezers, of course. Now the tweezers, oh, there it is. I'm panicking here. Okay, I will switch hands. See. Actually, I'm going to turn down the heat this time to 280 because it gets so darn hot. No, it's not good. Oh, it's the darn cardboard thing. Okay, let's try this. No, I'm going to 300 again. Let's see. Oh, there it goes. Nice. Nice. Good. Put it to the side. Next patient. Yep, this one totally off center. There it goes. Nice. Okay, so I cleaned up this board, so I'm quickly going to show you what it looks like. And as you can see, it looks clean, of course. The soldering looks nice, but to get a better view of what the soldering is like, for example here we can't really see what's going on, so we have to tilt it on the side. And I'm going to tilt it on the diagonal, I think. No, I'm going to tilt it on the side, and then you see this shows a really good example of a good solder joint. Because you can see the tin has a concave slope. If it had bald on it, it will be a sign that it's probably an old component with oxidation. But yeah, it seems like it worked really well. There's the SOT23. You can have a look at later. This is the diode. It looks really cool. And everything. So down here, SOT23 looks fine. Oh, there's a solder ball. I haven't cleaned away yet, so let's see if I can get it. Probably, yeah, it's probably a bit stuck. Yeah, I think I need stiffer bristles. So anyway, I don't like solder balls like that because you can get short circuits, in theory at least. So yeah, so that's it. That was what I wanted to say. This guy also looks good. Checked it earlier. So if you look at it on the side, this is what you see. I thought it was worse, but now I see it's not bad. Yeah, it looks good there too. There's a little diode again, which is the wrong part, by the way, or the wrong package size. But it works. So if I measure on the pads, it works. So yeah.